Hmm. Seems like I am live. Let's see. Yep, I am live. Now, PDF. Yes, yesterday we were on chapter number 2. We were about to complete chapter number 2, but we got stuck on a question. Let's see what that was. It was, yep, no, we did these and then conditional expressions. Huh, I think we read the function lower if did we complete this question? I feel like we completed the chapter. That was stupid of me. Yes, we did complete the chapter and we moved on to this new chapter. We did the switch statement and after that, did we do this? Yep, we did this and after that, we did all of this and yep, we did this question and after that, we moved on onto 2's complement representation. In 2's complement representation, our version of ITOA doesn't handle the largest negative number, that is the value of n equal to this. Explain why. Modify to print the correct value regardless of the machine on which it runs. I think this is the one. I think this is the question that we got stuck at. Let me go to the folder where I write my C code. Yeah, chapter 3. Yep. ls escape to visible binary search, and we have in a 2's complement representation number to string expand range escape visible dot c. In 2's complement number, our version of ITOA does not handle modify it so that the value correctly, this was it, right? Integer to string, number to string, yep, number to string. This was the function that we were struggling with, right? That is correct, right? Yep. This was the function that we were struggling with. And clang register.s. Oh, clang register is a different function that I was working on. Send the output dot output and this, yep, segmentation fault. Why am I getting a segmentation fault when I'm doing this? That was the problem, right? While, okay. Is it because this is not returning a number? Not console.log. Printf, let me keep printing the number. %d, new line, and n. Not slash n. N is not reducing, that is the problem. Yep. N remains same. Why is that? N equals n divided by 10. Why does n remain? Oh, why isn't n's value? Shit. Is it because of this? Yep, seems like it. I think now it will work. But this did not successfully reverse the string. I wanted to reverse the string. Yeah. Yep, this function is not reversing the string. Integer I. I take an integer I which starts at 0 and then goes till the end. And then I start integer j which goes up to I and it starts replacing the strings. So Let's say I get 001 in the string, and then I will go up to, wait, yep, and then I will go to 001 and null. I will go up to 3. So here I have j started at 0 and I is 3, and then I store j, that is 0th character, which is also happens to be 0. So 0 goes into the temporary variable, and then the first position comes 3 minus 1, that is 2, minus 0, that is the 0 1 2, which is 1. So 1 comes at the first place, and at the last place where 1 originally was comes the temporary variable, which is 0. So they are getting replaced. But what is the problem? Am I not calling reverse? Yes, I am calling reverse here. Let me not call reverse here and then see what happens. Then also the same thing. And when I am calling reverse, then also the same thing. This is not working properly, even though I am calling reverse with the character string, with the same string that I have been working with, which has been passed down to me generations after generations. Now let me reverse the string here, and let's see what happens. Okay, that is not working. What do I give it? Something else. 1 2 3 4 5 clang. Well, let me remove the second reverse, which is just bad, and let's see the result now. And it got reversed, even though it is a string, but it got reversed. If I do not reverse it, then it also gets reversed. It is not making sense. ITOA, calling ITOA on stir, and here I am taking stir as S, and here then I work with S, and then here in the void, in the reverse function, I am reversing S. This does not seem to be working. Why is this function not reversing anything when I'm calling it here? Reverse with S. It should work, but it is not. Even though I am able to convert this 1 2 3 4 5 into a string, still I am messing up somewhere. The reverse function seems absolutely correct, and ITOA, integer to ASCII, is also correct. It has a I, and it also has a sign. I is initialized at 0, and if the number is less than 1, is less than 0, that is, if it is negative, then I take the negative of n, so that it starts with positive numbers. Do something, do SII, that is starting from 0, make the characters in S equal to the Starting from the first place, make the characters in the string S or array S equal to the last remainder of n, and also keep reducing n by 10. That is, keep removing the last value from n. Now, why is that? If sign was less than 0, then add a negative sign, and if it was, and then after adding the sign, then put s, put the last character equal to null, and then reverse the string. Okay, and in reversing the string, I first get the length of the thing, but does this not give me the length? This might be the thing. Ah, the bug might lie in this. Maybe this thing is not giving me the length. Will this C code give me the length of the string? Yes, the loop. This iterates through the string S character by character until it reaches the null terminator. The value of I after the loop completes will be the length of the string excluding the null character. Including the null character. I will get the value of the null character. I will point to the null character. Oh, well, this will give me the length. And since index starts at 0, therefore I will get the length. But then this is also not reversing the string. Number to string, recompile and run, and no change. And after I put the reverse function there, still no change. Let me ask ChatGPT. This function is not reversing the string S. This function is not reversing your function has a couple of issues. It doesn't swap characters correctly because you are going beyond the midpoint of these. Oh, I am going beyond the midpoint. This has to be less than equal to I by 2. Now it will work. I was going beyond the length of the string, therefore I was reverse swapping the characters and then re-swapping them to so that it becomes the opposite again. Even though I made it correct the orientation, I corrected the orientation, but then I went beyond the index of swapping midway, and then I started reversing it again, which messed up the orientation again. Exercise 3.5. Write the function itop, integer to binary, which taken as n, which takes n as b, that converts the integer n into a base b character representation in the string s. Okay, s is the string, n is the number, and b is the base. In particular, this formats s as a hexadecimal integer. etob converts integer n into a base b character representation in the string s. Okay, number base change string dot c, include stdio.h and int main void, not no void here. This function will not return anything, and it will be itob. It will take in an integer n and a char pointer s and an integer base b, and then it will start looping. How do I convert one base from one base to another? How can I convert by, let's say I have, which accepts the integer n that converts integer n into a base. I am supposing that n is in base 10, converts into a base character b. So draw, if n is a base 10 number, let's say 5, 3, 6, 1, and I have to convert this into hex. Okay, that is b equals 16. I have to convert this into hex. What do I do? I can start from the start or start from the end. Well, let's start from the end and let's see what this does. I can the starting value can be 1, 2, 3, 4, 5, 6 till 15. So if I find the remainder of this thing with 16, the remainder of this whole thing, that would be 5, 3, 6, 1, remainder 16. Okay, 1 is the remainder, so I get 1 as the remainder. And how do I reduce this number? By dividing it by 16. Let's see, the first remainder I get is 1, and then if I divide this by 16, 5, 3, 6, 1 divided by 16, I get 3, 3, 5. Now the number becomes 3, 3, 5. I don't know if this is correct. Then I will find the remainder with this. 3, 3, 3, 5, remainder 16. That is 15. And 15 is represented by F. Am I doing correct? I have to see that the first place represents 1. The second represents 16. The next represents 16 into 16, 256. I guess it is 256. 256. And then next, that should be enough. Nope, it is 5,000. And 5,000, yeah. Let me see, first 16 into 16, yep, 256, and then 16, 4,000, 9, 6, 4, 4096. Okay, I have to see how many times do I add this. This number has to be this number 53661 has to be equal to some number multiplied by this plus some number multiplied by this and some number multiplied by this, and then when I add all of these, then I should get this number. So and if I do 4096 by 1, I get 4096. and to that, so I have to reach 5361 and I already have 4096. Now I have to get the remaining value, and the remaining value is 562 and to get 265 I can get one of this one of this, and when I get one of this I get 256 exactly, and what remains is 9, and to get 9 I do not want to get 16, so I put 0 here, and to get 9 I put 9 here. So the answer is 1109 in hex represents this. Okay, let's see. Hex to decimal 1109. 1109. 4361. That is not our number. Oh, my bad. It is. There is also this one here. Okay. There is also this one here, not 265. There is also this one. So to get this value, how many times do I have to multiply 256? I can multiply 256 by, if I multiply it by 4, I get 1000. And then if once more, that is if I multiply it by 5, what do I get? I get 1250 plus 30, 1080. So 1280, but that is off shooting, so I will take 4. And when I do that, what do I get? I get 1000 and 6 4 is 24, 1024. Okay, and after subtracting 1024 from this, my new remainder is 24221. And what can I multiply 16 with to get 221? If I multiply 16 by 10, I get 160, and if I multiply 16 by 5, I get 80, and 160 plus 80 is too much. 160 plus 80 is 240. 240 is overshooting again. Right, and I did the subtraction correctly, right? Nope. Nope. This is supposed to be 4. Yep, I get 240. So if I multiply this 16 by f, which is 15, I get 240, and the last remainder is 1. To get 1 and from the first place, I add 1, which results in this number, this addition. This was top-down approach. But this does not feel very natural because I would also have to calculate these numbers, and I do not want to calculate these numbers because I would have to start with a bigger number and then going down by doing this. So I want to start with this number, and I want to see remainder of this number and get that remainder added to my value to my okay. So here is the plan. I will get number 5371, whatever. I will have a string s which is empty to begin with, and I will have a base which is 16. Let's say it is 16. Then I will find the remainder of this number and whatever is the remainder I will add it to the string. I will add the remainder to the string and then divide the number by that by divide the number by 16, right? Yes, okay, that sounds about right. Int I do what? First of all, yes, also the sign int and I add sign I equals not I if n less than if sign equals n less than 0, then do n equals minus n. And what do I want to do? I want to do also I equals 0 and si equals the remainder, but I also want the remainder to be good. Okay, I will find the remainder. Int rem equals n divided by b, not divided by, remainder is this sign, modulus sign, remainder. If rem greater than 9, then I want to change it. How do I change it? I do rem equals wait char, and if rem equal greater than 9, then I can do a will represent 10, so rem minus 9 will give me 0. If the answer is 10, will give me 0. I will add to it a, capital A. This will give me the value, right, that I want. And else, that is if it is not so, then rem equals rem plus 0. Okay, and then si plus plus equals rem, and then here while do this while n equal divided by equals base is greater than 0. Okay, that makes sense. And then I would like to reverse the string. For that I can use this reverse function that I wrote here. Copy this here, and then yes, also if I want to add the sign after, here, if sign less than 0, then si plus plus equals this, and then si plus plus equals the null character, and then reverse S and go to the top, and also I will add this function as a prototype above. Yep, and then I will just call it. Yes. First of all, let me get a string stir which has 100 elements, and then let me call itop function with the number. Let's use the number that we took for our example. 5361. 5361, and string is this, and the base is 16, and then just printf %s new line and stir. Let's see, blank number base, send the output dot out, and let's see, 14G1, that is G. What the heck did I got G? I'm not supposed to get G. I'm not supposed to get G. F is the last one. Okay. I get it. Because here I subtracted 9, and if the number is 10 and I subtract 9, I will get 0 instead of 1. I will get 1 instead of 0, but I want 0. So 14 F1. Now it is correct. S function is yes. Write a function of itoa integer to ASCII that accepts 3 arguments instead of 2. The third argument is a minimum field width. The converted number must be padded with blanks on the left if necessary to make it wide enough. That is doable. Number to string with padding dot c, include stdio dot h int main, and in here nothing goes out of here. Void integer to ASCII and integer n, character pointer s, and integer width, and then I'll say int I, and then sign gn, not sing, sign if sign gn equals n. If this is less than 0, then make n equals minus n, and then do something for me. Do what? Well, first, before that, I equals 0 seems like a good thing to do, and then do si plus plus equals remainder, right? Yes, what is the remainder? Remainder is n remainder 10, and to that I will add 0. Yep, that is a good deal. And then do this while n divided by equal to 10 is greater than 0. And then after doing that, put s if sign less than 0, that is if it is negative, and don't do this stupid, then n, not n, si plus plus equals a negative sign, and then si plus plus equals a null character. This is the null character, and then I will reverse s. How do I reverse s? The courtesy of this function bn and this y 26, go to the top, do this, do this, do something of like this, something like this, and this. Yep, now I can reverse the string. Why is s an error reading? Now it is not. Yep, after reversing the string, no, I have to do this before reversing the string and before adding the null character. If I less than width, no, not if, but while I less than width, what do I want to do? Si plus plus equals space. Yep, and then at the end add this and reverse the string. Ah, that seems awfully correct. And then I will get an integer array of 100 characters and call the itoa function with the number. My number is minus this number, and string where I want to store the answer is str. And what should be the width? Width should be 10. And then printf %s new line comma str. This should work. Clang number to string with is padding. Send the output to the output and it works. I have the padding that I wanted. Got everything I wanted. And now this break and continue. And then go to labels and then chapter finished. That is crazy. And we do not have any questions before the end of the chapter. We can end the chapter simply. And after that, we can move on to the next chapter. And it has only been 37 minutes. And in 37 minutes, we only wrote 3 functions. That is not good. That is slow, but that is also good. We are at least writing some functions, right? It is sometimes convenient to be able to exit from a loop other than by testing at the top or bottom. The break statement provides an early exit from for, while, and do. Just as from switch, a break causes the innermost enclosing loop or switch to be exited immediately. The following function, trim, removes trailing blanks, tabs, and new lines from the end of the string, causing using a break to exit from a loop when the rightmost non-blank, non-tab, non-line is found. When the rightmost non-blank, okay, trim, remove trailing spaces. Does it start from the end? N equals 0, n equals, yep, it starts from the end. And if the current character is not a space, not a tab, and not a new line, then break, else make this the end of the string. Yep. But why is he doing n plus 1 here? Because I started from the end. Let's say the string has length. Oh, okay. Is that correct? Let's say the string has length 5, and in 5, the first 2 are characters and the last 3 are blank spaces which we want to remove. And at After these five characters, after these five bytes, we have a byte that stores the null character. Hmm. So Sterling will return 5 and we will start doing our process at 5 minus 4. 5 minus 1, that is 4, and fourth index points to the last character among the 5, which is a space. And let's say this is not it. Uh, yep, yep, it is greater than equal to 0. And this is not satisfied, so I will move on to this. And n plus 1 equals this. And n plus 1, what is n plus 1? N plus 1 is 4 plus 1, 5, which is already a null character. Okay, but then we will go with the now n will be reduced by 1 and I will get 3 instead of 4. And when n is 3, it is also a space. It is the middle space. And when I get that 3, and this is also again false, and then I will get 3 plus 1 equals null. I will make the last 3 plus 1, 4, 4 equals null. Fourth character in the string will become null, which was the last space. Okay, and then we will come on. Well, this is better as a thought experiment, I guess. But let's say I have A, B, and then space, space, space. This is zeroth character for 2, third, and then 4. And here I have null here. When n equals 4, I will see that this is a space and I will make null equals 4 plus 1. This is already null. When n is 3, I will see that this is a space. Therefore, I will make n plus 1, this a null, 4 a null. And then n becomes 2 and then I will see that n is a space. Therefore, I will make n plus 1, that is 2 plus 1, 3 null character. This will become null. And then I will say C, that n will become equal to 0, which is a character, and then I will get out. So I will leave 1 here. What is that? Is that intentional? Sterling returns the length of the string. The for loop starts at the end and scans backward for the first character that is not a blank, a tab, or a new line. The loop is broken when 1 is found and when n becomes a negative. That is, when the entire string has been scanned. You should verify that this is the correct behavior even when the string is empty or contains only white spaces. The continuous statement is related to break. So I guess they are supposing that this is a new line character and that is why they do not want to skip it or at least keep something here, right? Space here. Yep, the continuous statement is related to break but less often used. It causes the next iteration of the enclosing for while or do loop to begin in the while and do. This means that the test part is executed immediately in the for control. In the for, control passes to the increment step. The continuous statement, it causes the next iteration of the enclosing for while and do loop to begin in the while and do. This means that the test part is executed immediately. Immediately in the for, control passes to the increment statement. The continuous statement applies only to loops, not to switches. Continue inside a loop causes the next iteration. A continue inside a switch inside a loop causes the next iteration. Yep. As an example, this fragment processes only the non-negative elements in the array A. This fragment processes only the non-negative elements in the array A. Negative values are skipped. this fragment. For I equals 0, I less than, and if I then continue. Okay. The continue statement is often used when the part of the loop that follows is complicated. So that revising a test and indenting another level would nest the program too deeply. Then we can use continue loops to start the loop again. Okay. C provides the go to infinitely abusable go to statement and labels to branch to. Okay. Formally, the go to statement is never necessary, and in practice, it is almost always easy to write code without it. We have not used go to in this book. They have not used go to in this book. Okay. Here we have error. Nevertheless, there are a few situations where go-tos may find a place. The most common is to abandon processing in some deeply nested structure, such as breaking out of two or more loops at once. Yep, breaking out of two or more loops at once. The break statement cannot be used directly since it only exits from the innermost loop. Thus, for if disaster, go to error. And here is the error. Okay, this organization is handy if the error handling code is non-trivial and if errors can occur in several places. Okay, a label has the same form as a variable name and is followed by a colon. It can be attached to any statement in the same program as the goto. The scope of a label is the entire function the function where the label is defined, and a label has the same forma as a variable name and is followed by a colon. It can be attached to any statement in the same function as the goto. Okay. And as another example, consider the following of determining whether two arrays A and B have an element in common. One possibility is for I equals 0, I less than n, and j equals 0, j less than m. If I equals j, then go to found. Yep, didn't find any common elements. Found, got one. Code involving a goto can always be written without one. One thought perhaps at the price of some repeated tests or an extra variable. For example, the array search becomes found equals 0. Oh, if this equals this, if found, I will do get one and else nothing. With a few exceptions like those cited here, code that relies on goto statements is generally harder to understand and to maintain than code without gotos. Although we are not dogmatic about the matter, it does seem that goto statements should be used rarely, if at all. We get you, Kernighan, Mr. Kernighan, and Mr. Ritchie. That makes sense. So we have completed this chapter, which concerns itself with control flow, how control flows, statements, blocks, switches, loops, and stuff. Now, chapter number 4, which is functions and program structure. How long is this? Page number 62. It starts here. Basics of functions. We can write functions, okay, and then and then functions returning non-integers. Okay, we can do that. External variables. Okay, and then we have a lot of questions that is going to be crazy, and scope rules. Then we have header files. Then we have static variables. Then we have register variables. Then we have block structure. Yeah, initialization, initialization, recursion, the C preprocessor, file in macro, substitution, conditional inclusion, Okay, that is a long chapter. That is a long chapter, but we got it. That is a long chapter, but that is also a good chapter. And we start. This is page number 2. First, we did a tutorial introduction, then we did types and operator expression, then we did control flow. Now we are at functions and program structure. Then we will have pointers and arrays, then structures, then input and output, then the Unix system interface, which is going to be good. We only have about 100 pages left, and if we only do 10 pages per day, we will be done this month. This is what the heck is this month? This is February, and we have 28 days. This is not a leap year, so yep, we got it. Page number 63, I guess. Yep, yeah. Functions break large computing tasks into smaller ones and enable people to build on what others have done instead of starting from scratch. Appropriate functions hide details of operation from parts of the program that don't need to know about them, thus clarifying the whole and easing the pain of making changes. My camera is working, stream is working, that is cool. Easing the pain of making changes. C has been designed to make functions efficient and easy to use. C programs generally consist of many small functions rather than a few big ones. Okay. A program may reside in one or more source files. In one or more source files. Source files. Okay. A program may reside in one or more source files. Source files may be compiled separately, loaded together, along with previously compiled functions from libraries. Okay, we will not go into that process here. However, since the details vary from system to system, function declarations and definitions in the area where the ANSI standard has made the most changes. Okay, is the area where the ANSI standard has made most of the changes in function declaration and definition. As you saw in chapter 1, it is now possible to declare types of arguments when a function is declared. The syntax of function declaration also changes so that the declarations and definitions match. Okay, the syntax of function declaration also changes so that the declarations and definitions match. This makes it possible for a compiler to detect many more errors. This may makes it possible for a compiler to detect many more errors. This makes it possible for a compiler to detect many more errors. This makes it possible for a compiler to detect many more errors. This okay because the syntax of function declaration also changes so that the because the syntax of declaration and definition matches. This makes it possible for a compiler to detect many more errors than it could. Furthermore, when arguments are properly declared, appropriate type conversions are performed automatically because the definition for the function declaration, the syntax for function declaration and definition matches. Therefore, the compiler knows what goes in and what comes out, and thus it can ease it can catch more errors than it would have otherwise. The standard clarifies the rules on the scope of names. In particular, it requires that there be only one definition of each external object. Okay. Initialization is more general. Automatic arrays and structures may now be initialized. Initialization is more general. Automatic arrays and structure may now be initialized. Okay. The C preprocessor has also been enhanced. New preprocessor facilities include a more complete set of conditional compilation directives, a way to create quoted strings from macro arguments, and better control over the macro expansion process. Okay, the preprocessor has had some enhancements so that we can use better macros and control the macro expansions at the time of pre-processing. That is cool. 4.1 Basics of Functions. To begin with, let us design and write a program to print each line of its input that contains a particular pattern. To begin with, let us design and write a program to print each line of its input that contains a particular pattern or a string of characters. This is a special case of Unix program grep. For example, searching for the patterns of letters out in the set of lines. This love, could you and I with fate conspire to grasp the sorry scheme of things entire? Would not we shatter it to bits and then remold it nearer to the heart's desire? Will produce the output. Love, could you and I with fate conspire? Would not we shatter it to bits and then remold it nearer to the heart's desire? The job neatly falls into this while there is another line. If the line contains the pattern, then print it. Ah, three functions. Although it is certainly possible. I want to read it again once more. Ah, love, could you and I with fate conspire to grasp this sorry scheme of things entire? Would not we shatter it to bits and then remold it nearer to heart's desire? That is actually sounds good. Ah, screenshot. Yep, now, although it's certainly possible to put the code of all of this in mean, a better way is to use structure to advantage by making each part a separate function. Three small pieces are better to deal with than one big one because irrelevant details can be buried in the functions and the chance of unwanted interactions is minimized and the pieces may even be useful in other programs. Yep. While there is another line is getLine, a function that we wrote in chapter 1, and printed is printf, which someone has already provided for us. This means we need only write a routine to detect whether the line contains an occurrence of the pattern. We can solve that problem by writing a function stir index st. Yep, stream is working fine. I heard something. It's been 57 minutes. Okay. We can solve the problem by writing a function string index st that returns the position or index in the string s where the string t begins or -1 if it does not contain t. Okay. Because C arrays begin at position 0, index will be 0 or positive, and so a negative value like -1 is convenient for signaling failure. When we later need more sophisticated pattern matching, we only have to replace string index. The rest of the code can remain the same. The standard library provides a function stir that is similar to stir index except that it returns a pointer instead of a index. Okay. Given this much design, filling in the details of the program is straightforward. Here is the whole thing, so you can see how the pieces fit together. For now, the pattern to be searched for its literal string, which is not the most general of mechanism. We will return shortly to a discussion of how to initialize character arrays, and in chapter 5 we will show how to make the pattern a parameter that is set when the program is run. The pattern as a parameter that is set when the program is run. Okay, that is also cool. There is also a slightly different version of getLine. You might find it instructive to compare it to the one in chapter 1. So here we have getLine, which takes in a character array and limit and I equals 0 while limit is greater than 0 and I do not get end of file and I do not get new line. I will put that character in the character array S. And then if the character is a new line, that is I ended at a new line, then I will put new line character at the end, and then return by adding null character at the end. Yep. That is get line. And here we have star index. For this we initialize ijk, three integers, and how can we compare if a sequence of a string is present in another string? We can start by going through the target string, going through the string in which we want to find the sequence, starting from its start, like this, starting from its start, and whenever I find a pattern, whenever I find that the current character in our target S string matches the first character of our source string which we want to find, then I will start looping over it and see if from that point the whole string is present there or not. And if it is, then I will return the first index, and if it is not, then I will continue from the next index for I equals 0, as I is till I am at null, uh, 0 character. I will increment I, and then for j equals I will start j at I and k equals 0. Okay, I will do if the target is not equal to null, that is I have not reached the end, and s, and currently they are equal, I will do j I k g plus plus k plus plus if k greater than 0 and the last is null, then return I, else return -1. Mhm, mhm, mhm. K will start at 0. Okay, J will start at, okay, okay, I get it. Makes sense. Yep. Then each function definition has the form this. It starts, the function starts it takes the first character. Let's say it starts with the first character and sees is this, and let's say each is the target string which you want to find in this string. So it will start in the target string's first character, and it will try to match each with this, but since it does not match, then it will move on to the next character A and start to match each starting from A, and if it matches, then okay, but and then it will just keep moving forward one character by character till it reaches the end of the string. Now you tell me, various parts may be absent as a minimal function is this, which does nothing and returns nothing. A do nothing function like this is sometimes useful as a placeholder during the program development. If the return type is omitted, int is assumed. A program is just a set of definitions of variables and functions. A program is just a set of definition of variables and functions. Communication between the function is by arguments and values returned by the function and through external variables. The functions can occur in order in the source file, and the source program can be split into multiple files so long as no function is split. Yes, we can split the source program into multiple files. That is crazy. And then the return statement is the mechanism for returning a value from the called function to its caller. Any expression can follow return. Return and then expression. The expression will be returned from that function. The expression will be converted to the return type of the function if necessary. Parentheses are often used around the expression, but they are optional. The calling function is free. The calling function is free to ignore the returned value. The calling function is free to return the is free. The calling function is free to ignore the return value. Yep. It might catch the returned value or not. Furthermore, there need to be no expression after return. In that case, no value is returned to the caller. There need to be no expression after return, and we can write return and then semicolon. In that case, no value is returned to the caller. Control also returns to the caller with no value when execution falls off the end. Okay, and that is I do not have any return value, but the end of the program has reached. So it is called that the execution has fallen off the end of the function, falls off the end of the function by reaching the closing right brace. It is not legal, but probably it is not legal. It is not illegal, but probably a sign of trouble if a function returns a value from one place and no value from another. Oh, if a function returns one value from one place and no value from another. In any case, if a function fails to return a value, its value is certain to be garbage. Its value is certain to be garbage. Okay. The pattern searching program returns a status from main, the number of matches found. This value is available for use by the environment that called the function. Okay. The when does it return that from the main? Where is the main function? Yep, main. I initialize a line, character line, and found is 0, while get line is greater than 0. I will get the line if stir line is greater than equal to pattern. That is, if I found the pattern, then print that line and increase the number found, and then at the end return found. Okay. The mechanics of how to compile and load a C program that reside on multiple sources vary from one system to another. On the Unix system, for example, the cc command mentioned in chapter 1 does the job. Suppose that three functions are stored in three files called main.c, getline.c, and index stir-index.c. Then the command c and the name cc. I can use gcc, C compiler, or GCC. Oh, at that point, the GCC compiler did not exist. I guess there might have been the GNU project, but maybe the GCC compiler did not exist back then. Then, then the command this compiles the three files, placing the resulting object code in files main.o, getline.o, and sterling.o. Then loads them all loads them all into a executable file called a.out. If there is any error, say in main.c, the file can be recompiled by itself and the result loaded with the previous object files with the command this. Oh, if there was some sort of error in the main C file and it was not compiled, then and only the getline and stir index files were compiled, that is, they were converted to their equivalent object files, then I can join those already compiled object files with my main.c file like this. The cc command uses the .c versus .o naming convention to distinguish between source files from object files. Now, a question that is good. Write the function stir index, which returns the position of the rightmost occurrence of t in s or -1. If there is none, that returns the rightmost occurrence of t. Uh, Make a new directory called chapter 4 or chapter 4. Go there in chapter 4 and write find string index.c, and here I will have include stdio.h, and then int main, and inside mi in the center of the screen is I seem to be the Assyrian Empire. Now this function will return an integer. The name is stir index, and it will take in two character pointers s and star t. And what is it going to do? What is it going to do? It is going to start with, well, a few integers, integer I, comma j, comma k, let's say, and it will start and from I equals 0 and till si is not equal to the null character. It will go on going. Now I would like to see a few things. First of all, if si equals char 0, the first character in char, not char, what the heck is char? The first character in t, then I know that the current character there matches that. Then I would like to go through. Now I will initialize k equals 0, or maybe j equals 0, and yeah, that seems good. J equals 0, and while t tj degrees, while tj equals si, what would I like to do? I would like to, well, remove these curly braces. While this is true, I would like to do j plus plus. Yep. While this is true and tj is not equal to null. Now I want to check that did I reach the end of the word that I wanted to search. So if tj equals null character, that is I found what I was looking for, I will do a return I plus what j, can I add j to it? Let's say I plus j is the length of that string, and I is the I points to the first character where I found it. So yep, I plus j minus 1 would be much better. And then if nothing like that happens, then return just return -1. And I did not use any care, so this is good. And wind is winding quite a lot today. What are the character arrays? Character arrays equals, and this is my character array where I am going to look for the index of the character below. Can char t equals, let's say, going, and then printf percent d new line, and the answer is std index. It should have been str index, but okay. Let's copy this, go up, do this, and yep, and then do clang find string.s and send the output to out, then do dot slash out, and my son, that is, I did not find what I was looking for, but I should have found it because going is here and going is also there, and this should have returned. While tj equals I and tj is not equal to the null character. Now, if tj equals to the null character, then return that number. What the heck is the problem now? Let's do a printf. Percent d, I would like to print the character I, the value of I, the value of the I, the value of I. 39 and 43. Find string C. So if I do, I should do 39. Yep, 39. Yep, I found it. 39, I found it here. And then after that, oh, I'm not increasing I here. That is also true. Let me do k equals I. No, or I can do instead of I plus j, because j starts at 0, and yeah, that would be good. I plus j clang, and then yep, that is not what I was looking for. Yep, do not print that, not slash out, and I got 43. 43 is the answer, right? 43 is the answer, right? If I go over here and do move right 43 spaces, nope, I moved 20 spaces, right? Move right 43 spaces, then yep, I got the correct answer. Now moving on to the next part, functions returning non-integers. So far our examples of functions have returned either no value, that is void, or an integer. Yes, what if function must return some other type? Many numerical functions like square root, sine, and cos return double. Other specialized functions return other types. To illustrate how to deal with this, let us write and use function in ASCII to float, which converts the string s to its double precision floating point equivalent. To its double precision floating point equivalent. That is crazy. ATOF, if an extension of ATOI, which showed versions of in chapter 2 and 3. It handles an optional sign and decimal point in the presence or absence of either part of fractional part. In the absence of either part or fractional part or fraction, our version is not a high quality input conversion routine that would take more space than we care to use. The standard library includes A2F. The header is this. Okay, the header this declares it. First, A2F must itself declare the type of values it returns. That is, A2F returns double, takes in a character array. The type name precedes the function name. If the type name precedes the function name, precedes. Double, we initialize a double value and a double power, integer I and sign to iterate, and double value stores the value, and power stores the power. For I equals 0 is space I plus plus. Oh, skip the initial white spaces. That is cool. Sign equals SII equals this. If this is equal, then sign becomes -1. Otherwise, it becomes 1. If SI equals plus or -1, then I plus plus. That is move on to the next value. Then for value equals 0.00 is digit. If it is a digit, then do this and make value equals multiply value by 10 and add to it the number. Okay. While it is digit, and at the end, if I is a point, I will move past it, and power becomes this, and value equals value into 10 plus. Value equals value into 10 plus that number, so that to do that, and at the end I can do answer is sign into value divided by power. That makes sense. That would work. Second, and just as important, the calling routine must know that ATOF returns a non-integer value. One way to ensure this is to declare ATOF explicitly in the calling routine. The declaration is shown in this primitive calculator, barely adequate for checkbook balancing, which reads one number per line, optionally proceeded with the sign and adds them up, printing the numbers sum after each input. Okay, what is it doing? It is taking a double and a sum, and what is it taking? It is taking the return value of ATOF for an empty string, it seems. No, 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 no. It is it defining it? Oh, this is defining that I have a ATOF function which takes in a char and returns a double value, and I am declaring that inside my main function. That is just crazy. Then character array called line, which has max line, that is 100 bytes of character, and then I have integer get line. This is a goddamn header file, it seems. While sum equals this while get line integer get line character. This is the declaration for get line function. Then I have sum equals 0 while get line and maximum line greater than 0. I will printf tab and then percent g g percent g, and okay, g is a way to write numbers using the printf function. This will give me sum plus ATOF for that line. Okay, this will just keep adding the number to the sum. Double sum ATOF char says that sum is a double variable and that ATOF is a function that takes in one character string argument and returns a double. The function ATOF must be declared and defined consistently if ATOF itself and if ATOF and the call to it in main have been inconsistent types in the same source file, the error will be detected by the compiler. The function ATOF must be declared and defined consistently. Must be declared and defined consistently. That is, its declaration and its definition should be consistent with each other. The stream is working, and here we have a panel from Chainsaw Man, which is just crazy, and I can remove my charger. Yep, here. Aha, I'll page up, page down. Now, the function ATOF must be declared and defined consistently. If ATOF itself and the call to it in main have inconsistent types in the same source file, the error will be detected by the compiler. That makes sense. If the definition and the if the definition of ATOF and call to itself have different data types, then I will get an error by the compiler. But if, as is more likely, ATOF were compiled separately, the mismatch would not be detected. Okay, ATOF would return a double, and that main would treat as an integer, and meaningless answers would result. In the light of what we have said about how declarations must match definitions, this might seem surprising. About how declarations must match definition. This is not surprising, that is how it should be done. The reason a mismatch can happen is in the light of what we have said about how declarations must match definitions. This might seem surprising. Declarations have to match definitions. When I declare something and when I define it, then they have to be same to be consistent with each other. The reason a mismatch can happen is that if there is no function prototype, a function is implicitly declared by the first appearance in an expression, such as this. If a name that has not been previously declared occurs in an expression and by a left parenthesis, is followed by a left parenthesis, it is declared by context to be a function name. Okay, the function is assumed to return an integer and nothing is assumed about its arguments. Furthermore, if a function declaration does not include arguments, as in this, that too is taken to mean that nothing is to be assumed about the arguments of ATOF. All parameter checking is turned off. Okay, all parameter checking is turned off. Not that. This does not mean that the input parameter is void. This means that all parameter checking is turned off so that if I enter anything, I won't get any error. This special meaning of the empty argument list is intended to permit older C programs to compile with new compilers. Okay, because in older C programs, definitions for functions was much more open-minded but then it wasn't due in the ANSI standard of the C language. But this it has been like 30-40 years since this book was written, so now we will get error when I do this. This special meaning of the empty argument list is intended to permit older C programs to compile with new compilers. But it is a bad idea to use it with new C programs. If the function takes argument, declare them. If it takes no arguments, use void. Given ATOF properly declare properly declared, we could write ATOI convert a to integer in terms of this. Okay, we can convert ATOI to integer. We can define ATOI using ATOF. First, we can convert the given string into a double, and then we can convert that double into an integer and then return with that. That is also crazy. Notice the structure of declaration and the return statement. The value of the expression in return expression is converted to the type of the function before the return is taken. Therefore, the value of ATOF a double is converted automatically to int when it appears in this return. Since the function ATOI returns an integer, this operation does potentially discard information. However, so some compilers warn of it. The cast states explicitly that the operation is intended and suppress any warning. Oh, this cast states explicitly, do this, I want you to do this. Okay, then extend ATOF to handle scientific notation of the form. This where a floating point number may be followed by E or E and an optionally signed exponent. Where a floating point number will be followed by small e or capital E and an exceptionally optionally signed argument. Now, float with scientific notation dot c include stdio dot h, right, like small h, and then int main and void and nothing in the function, and then double ATOF. It will take in a character string s and nothing else. Would it need anything else? Nope, nothing. And then inside I will declare a few things. Int I and assign, and what else do I need? A power and value. Double value and power. Value will store the value that we are storing the value, and power will store the power with which at the end I will with which I will at the end I will divide the value. And now I equals 0. I will skip the white spaces for I equals 0. I is not I, but si is not equal to spaces I plus plus. Yep. Now at the end, this function skips the spaces at the front, and now I want to see what the thing is. Now if si equals minus, oh, not a if statement, sign equals si equals minus sign. If it is equal to minus sign, then return minus 1, else return 1. Now if si equals minus or si equals plus sign, I would like to do I plus plus, and then the thing begins. While s bracket I is not equal to either end and si is also not equal to, what is the scientific notation? This thing. Oh, while it is a digit. While si is a digit, I want to continue this. While is digit. What is digit? Si. While si is a digit. What do I want? Yes, I want to continue this. And what is this? Na starts at 0, not n. Not n, but value starts at 0. What would I like to do? Value equals value into 10 and some brackets to make everyone happy, and then add to it si minus 0 to get the value. I can omit these braces. Now after that, I know that if I can do plus plus here. If si equals a dot, then what do I do? Then I do I plus plus and continue. Then I do I plus plus and continue, but it could also be not a dot. Yes, if it is a dot, then I skip, and if it is a dot, the next character is a dot, then I skip and go to the next number, which in this example is 4. But it could be that I just encounter E. What if this is the number that I get? 445 E minus 1. So now I want to check. Yeah, I can do a while loop. While is digit si, that would work. Then make value equals value into 10 up, into 10 and add to it si plus plus and minus 0. Yep, that should work. And since I have to write another statement about power multiply equals 10. Yeah, and power starts at power equals 1. Power starts at 1. Okay, and then I would like to see if si now equals e or si equals capital E. If any of that is true, then I know after E I will have a shit. I might have a minus sign or a number. I might have a number or a minus sign followed by a number. Now, if now I am at E, then I would like to see if si plus 1 equals minus sign. If it is a minus sign, then I can do instead of doing this, I can make it plus, and here I can make power equals 0, or I can make power equals 0 here on here power equals this, and then here yes, when I know the next sign is minus, then I will do power minus si plus it might be a bigger number. Oh, yeah. Then if this is the case, then I want to increase I by 2, and while si is digit, I want to get yeah. So the thing is that at this point I want to get the exponent. Let's say I will store the exponent in xp equals 0. Okay, and if this is the case, then I do this, and yeah, I can do si plus plus here, and the last thing is minus, then I do I plus plus here, and also um here yes, I would also like to store the sign of exponent, like sign. If this is negative, then this exponent sign equals 1, and if this is negative, then sign equals minus 1. That is one way to store it. And then while is digit si, then exp equals exp into 10 plus si minus 0 character. Yep. This should give me the exponent by the end of this thing. By the end here, I should have the exponent, and then I would like to work with the exponent and subtract the exponent. Exponent multiply equals to sine, like not sine but exponent sine, and then power plus exponent. If the sign is positive, then exponent will be positive, and if sign is negative, then exponent will be negative, and it will be subtracted from power, and then I will have the correct power and return value divided by power. Is that correct? Just value divided by power. Value divided by power. How was it returned in the original function here? I guess it was just value divided by power. Sign multiplied by value. Sign. I also have to take care of the sign. Sign multiplied by value divided by not power but power. Sp but power raised to 10 raised to power. This should work. Es muss funktionieren. Es müssen funktionieren. What does this take? A random string, not a random string, a string. Let's say this is string char pointer str equals this and print this. Okay, and then I was thinking about console.log. L long, right? Percent long new line, and answer is ATOF and string shit to print double in C. How to print a double value in C? Percent F. Yes, percent F. F means float. Yes, F. Clang and send the output to out, and that is wrong. Maybe because of the exponent, because -6 is quite a bit long. Okay, the answer is correct. Wrong due to some reason. I am raising 10 to the power. Let me print value at this point. Control F, percent F, and power, percent F, new line, value, and power, clang, and run it. A value, power, everything seems to be goddamn 0. Where did I go wrong? With the go wrong? Where? My string is that which is above. Is it because it is a string literal and I cannot access string literal like that? Nah. That does not seem to be the problem. I get sign here and this while digit. Yep. Print formatted string percent character. Let me print the character SI, and with that also value, which is float, which is value. And since this is not a single line, I have to do this. Now clang. It didn't even got printed. Is digit SI is not working. Oh shit. I see the problem. I see the problem now. I see the problem. Maybe the problem is you. Yep. I see the problem. It is not supposed to be not equal to. It is supposed to be equal to. And still the answer is 0. Yep. FE, and now I guess I should see the correct thing. String, what is the problem now? While I equals in new equals white space, do this, and then sign equals if si, the current thing is this, then sign equals -1, otherwise not. And then if the current character is -1 or plus, then increase I, which is not true. Then at this point I have I equals 0, and then I make power value equals 0. Shit, power has the value 0. Power has no value. Power is only given to those who are prepared to lower themselves to pick it up. While is digit, while the character is digit, I would like to print it. Let me print the character while it is digit. Printf, print the character. Character is here. Control C, and value is also here. Command F, %F, and this, and value. This should work. Okay, character 1, 2, 3, and value also increases, but then at the end it messes up. Why is that happening? Okay, so at this point everything is correct, everyone is happy. Then I check for this, and which is true. Thus I increase I by 1, and then I go here. Let me print this again, and here also everyone is happy, no problem whatsoever. And then I am also increasing power by, okay, I have to increase power by 1, not by 10. That was a fatal error. I think I can even add the E here, E -6. No, E didn't work. Ragnar Lothbrok didn't succeed. After that, lang /out, and yep, we are messed up here. And okay, what is the problem? Now the problem lies in this lie. This is why the problem lies here. If I know that the current character is E, that is, I have some exponent after this, I increase I by 1. Okay, and then I check if it is -1 or not. Oh, not sign -1, but x sign should be equal to -1. And then I start a while loop to get the character. For the current thing, my this, now it should work. Okay, I see this, then I increase I by 1. If then I see minus, then I increase I by 1. Okay, that is consistent. At this point I should have the index for 6, the digit 6, and x sign is 0, and then while I is 1. Oh, it is always a digit. I have to plus here. Now it should work. We did that, and 6 minutes are remaining. I wanted to go to the washroom, but I will go after this. Okay, that is quite a bit. Where did we start today? This is page number 67, and we started at We started in the last chapter from here, page number 59. We have not done not even 10 pages today. That is crazy. So let us do 10 pages, at least 10 pages. We started at page number 59. Let us reach at least page number 69. That is a good page. A C program consists of a set of external objects. A set of external objects which are either variables or functions. A set of external objects which are either variables or functions. The adjective external values. The adjective external is used in contrast to internal, which describes the arguments and variables defined inside functions. Arguments and variables which are defined inside functions are called internal, otherwise they are called external. External variables are defined outside of any function, and are thus potentially available to many functions because they are outside all the functions. Functions themselves are always external because C does not allow functions to be defined inside other functions. So yes, functions are always external. By definition, by definition, external variables and functions have the property that all reference to them by the same name. By default, external variables and functions have the property that all references to them by name, even from functions compiled separately, are references to the same thing. Okay, by default, external variables and functions. Okay, if something is external, if something is external, either function or a variable, then all the references to them by the same name, even from functions compiled separately, are references to the same thing. So if I change an external variable at some point, that change can be seen by everyone else. The standard calls the standard calls this property external linkage. Okay, in this sense, external variables are analogous to Fortran common blocks, or I do not know Fortran. Fortran common blocks are variables in the outermost block in Pascal. We will see later how to define external variables and functions that are available only within a single source file. We will see later how to define external variables and functions. External variables. We will see how to define external variables and functions that are visible only within a single source file. We will see later how to define external variables and functions. External variables and functions that are only visible. We will later see how to define external variables and functions that are only visible with. Okay, I was being stupid and not reading it with focus. That was the problem. Now, because external variables are globally accessible, they provide an alternative to function arguments and yes, they provide an alternative to function arguments and return values for communicating between communicating data between functions. Any function may access an external variable by referencing to it by name if the name has been declared somehow. Okay, if a large number of variables must be shared among functions, external variables are more convenient and efficient than long argument lists. As pointed out in chapter 1, however, this reasoning should be applied with some caution, for it can have a bad effect on program structure and lead to programs with too many data connections between functions. Yep, that makes sense. External spaghetti code, spaghetti code is something we do when we are branching all over the place in assembly language. External variables are also useful because of their greater scope and lifetime, because of their greater scope and lifetime. Automatic variables are internal to a function. Okay, yep, that is why they are called automatic variables. They come into existence when the function is entered and disappear when it is left. External variables, on the other hand, are permanent, so they can retain values from one function invocation to the next. Thus, if two functions must share some data, yet neither calls the other, it is often most convenient if the shared data is kept in external variables rather than being passed in and out via arguments. That makes sense. If two functions have to share data but they do not want to be calling each other, then they can make then the programmer can make that data externally available to them. Let us examine this issue with a larger example. The problem is to write a calculator program that provides the operator plus minus multiply divide. Because it is easier to implement, the calculator will reverse polish notation instead of infix. Reverse polish notation is used by some pocket calculators in languages like Fortran and PostScript. Reverse polish notation, I have heard that before, and I think looking that up will be the last thing that we do. Like, not like in a reference to the whole life, but today. Reverse polish notation. What is reverse polish notation? And I think that polish does not mean Poland. Polish is the name of a guy, name of the person. Reverse polish notation is a mathematical notation which operates following operands, eliminating the need for parentheses. Ah, it is a notation in which we can specify arguments like this, in which we do not have the need for parentheses. Okay, how it works in the standard infix notation, an expression like this. Okay, this notation with parentheses is called infix. It has the Bodmas rule applies to it, and we have to solve parentheses first, and parentheses are used to specify the order of operation. This uses parentheses to indicate precedence. In a reverse Polish notation, the same expression is written as this. Okay, so a reverse Polish, how does this work? We start from here or from here. I guess from here. We start from here, we see one operand, then we see the next, and then we see a operation. We perform that operation on the operand that we have got till now. 3 plus 4, we get 7. And now our first operand is 7. Then we move on and we see 5. We add it to the second operand, and then we see an operation. So 5 multiplied by 7, 35. Push 3 onto the stack, push 4 onto the stack, encounter 3, encounter plus pop 3 and 4, compute their sum and push 7. Push 5 onto the stack, encounter multiply pop 7 and 5, compute 7 multiplied by 5 and 35, and push 35 onto the stack. That is good. No need for parentheses since the order of operations is implicit. Efficient computation using a stack, making it well suited for calculators and programming languages like Fortran and PostScript. PostScript, reverse polish, reverse post. Easier for PostScript. The thing is coming after. The operation is post. Easier for computers to parse compared to infix notation. Yeah, solving this is, I guess, much harder for computers. This is much easier. The whole algorithm is in 6 lines. Okay, and that is it for today. Tomorrow we will start from here, page number 67. And today, bye.